Welcome to the lesson on voltage. In this lesson, we will delve into the fundamental concept of voltage, explore how it is measured, and its significance in battery electric vehicles. Let us look at our lesson objectives. By the end of this lesson, you will be able to define voltage and explain its role in electrical circuits. Next, you will be able to identify the unit used to measure voltage. Next, you will be able to explain the different types of voltage levels in battery electric vehicles. Finally, you will be able to describe the relationship between current, voltage, and resistance in battery electric vehicle circuits using Ohm's law. Battery electric vehicles rely on complex electrical systems to power components such as motors, batteries, inverters, and onboard electronics. Understanding voltage is essential for comprehending how these systems function and interact. Voltage fluctuations or irregularities can indicate potential issues within the vehicle's electrical system. Technicians need to be able to measure and interpret voltage levels to diagnose problems accurately and perform troubleshooting procedures effectively. High voltage can pose serious safety risks if mishandled. Technicians must understand the significance of voltage levels and take appropriate safety precautions when working on high voltage components to prevent accidents or injuries. In this lesson, we will focus on the concept of voltage, the different types of voltages in battery electric vehicles, and the relationship between current, voltage, and resistance using Ohm's law. Voltage is defined as the potential difference between 2 points of a conducting wire. Imagine you have a water hose connected to a faucet. The hose's water pressure represents the electrical circuit's potential voltage. When you turn on the faucet a little bit, the water flows out of the hose with low pressure. This low pressure can be compared to a low voltage in an electrical circuit. Imagine turning the faucet handle further, increasing the water pressure in the hose. The water now comes out with more force. This increase in water pressure is similar to increasing the voltage in an electrical circuit. Likewise, when you increase the voltage in a circuit, the electrical energy flows with more force, allowing devices like motors to operate more effectively. So, just as increasing the water pressure in a hose makes the water flow with more force, increasing the voltage in an electrical circuit provides the necessary energy for electrical devices to function correctly. It is important to remember that voltage does not flow. It is the pressure that causes the electrons to flow, or the pressure that causes current. Voltage is the driving force that pushes electric charges through a circuit, much like water pressure drives the flow of water through a hose. Voltage is measured in volts using the V symbol. 1 volt is equivalent to 1 watt per coulomb. Battery electric vehicles use multimeters and voltmeters to measure voltage accurately. In this image, the battery electric vehicle is being charged, and the voltage is 242 volts. Voltage represents work per unit charge, which measures the force that pushes electric charges through a circuit. Voltage could be abbreviated as E, which stands for electromotive force. Voltage is critical as it determines the amount of electrical energy available to power the vehicle's components, including the motor and battery. There are 3 types of voltage levels: DC high voltage, DC low voltage, and AC voltage. DC high voltage is the primary battery pack voltage, typically ranging from 400 volts to 800 volts in most battery electric vehicles. High voltage systems power the electric motor and require specific safety measures due to the high energy levels involved. DC low voltage is a lower voltage system, usually 12 or 24 volts, power auxiliary components like lights, infotainment systems, and instrumentation. It's similar to the electrical system in conventional vehicles. AC voltage. Battery electric vehicles employ an onboard charger that converts AC power from the grid to DC for battery charging. The AC voltage level depends on the region and electrical service. The relationship between voltage, V, current, I, and resistance, R, in an electrical circuit is governed by Ohm's law, expressed by the formula V equals I times R. This law essentially states that the voltage across a conductor is directly proportional to the current flowing through it and inversely proportional to the resistance it offers. Let's say we have a simple circuit with a light bulb that has a resistance of 50 ohms, ohmega. We connect this bulb to a battery that provides a constant current of 2 amps, A. We can use Ohm's law, V equals I times R, to find the voltage across the light bulb, V. V equals 2A times 50 ohms. to equal 100 volts. Therefore, in this example, the voltage across the light bulb is 100 volts. This is a typical example of a low-voltage scenario you might encounter in a battery electric vehicle's low-volt system that powers accessories. Let us now recap what we have covered in this lesson on voltage. Voltage is the electrical pressure that pushes electrons through a circuit, similar to water pressure in a hose. Voltage fluctuations can signal potential problems within the vehicle's electrical system. Technicians must be able to measure and interpret voltage levels for accurate diagnosis and troubleshooting. Voltage is measured in volts V, with instruments like multimeters and voltmeters. There are three types of voltage levels: DC high voltage, DC low voltage, and AC voltage. Ohm's law highlights how voltage is directly proportional to current and inversely proportional to resistance within a circuit. By grasping voltage and its role in battery electric vehicles, technicians can accurately diagnose electrical issues, perform safe service procedures, and ensure optimal performance. Thank you.